Welcome to the Bare Metal Cyber Security Plus podcast. This series helps you prepare for the CompTIA Security Plus exam with focused explanations and practical context. For a companion study guide, check out the Achieve CompTIA Security Plus 701 Exam Success by Dr. Jason Edwards. It is the most concise and complete Security Plus guide on the market, built for busy professionals who want to pass the exam fast and on their first try. You can find this book and others at cyberauthor.me. In this episode, we are focusing on network-based indicators that signal an active cyber attack or unauthorized behavior in progress. These indicators are often found by monitoring traffic, reviewing logs, and watching for anomalies across network infrastructure. Today, we will examine two major categories of network-based threats: distributed denial of service attacks and domain name system abuse. Understanding how these attacks function and what signs they leave behind can help you detect and stop them before serious damage occurs. Let's begin with distributed denial of service attacks, commonly known as DDoS attacks. These attacks are designed to overwhelm a target system with massive volumes of traffic, making it unavailable to legitimate users. The goal isn't to steal data, but to disrupt operations, shutting down websites, blocking access to services, or degrading performance so severely that systems become unusable. DDoS attacks often originate from botnets, a network of compromised devices under the attacker's control. The attacker instructs all of these devices to send traffic to the same target at the same time. What makes DDoS so dangerous is the scale. Even modest attacks can saturate bandwidth, consume server resources, or exhaust firewall capacities. There are two common DDoS techniques you should recognize: amplification and reflection. Amplified attacks occur when small requests are sent to third-party servers, which then respond with much larger responses that are directed to the victim. The attacker's request is amplified in size and redirected. A common example uses open NTP servers. A single small request can trigger a massive response aimed at the target. Reflected attacks follow a similar pattern but add another layer of deception. In a reflected attack, the attacker spoofs the victim's IP address when sending requests. The servers receiving the request think the victim is the one asking, and they respond by sending traffic back to the victim, flooding it with unwanted replies. To detect DDoS attacks, administrators should monitor for traffic spikes, unusually large flows of data, and resource exhaustion. You may notice a sudden drop in server responsiveness, an uptick in dropped packets, or firewall logs that show connections from many different sources. If the attack is volumetric, bandwidth graphs will show sharp increases from one or multiple sources. DDoS mitigation involves several layers. Content delivery networks can absorb traffic and keep systems running during volumetric attacks. Rate limiting, geo-blocking, and black hole routing can redirect or reduce malicious traffic. Working with internet service providers and cloud-based DDoS mitigation providers is also essential, especially for high-volume attacks. Now let's move to domain name system-based attacks. The domain name system, or DNS, is how computers translate human-readable domain names into IP addresses. Because nearly every internet transaction begins with a DNS request, this system is a prime target for attackers. One major DNS threat is spoofing. In a DNS spoofing attack, the attacker returns a false DNS response to the victim, redirecting them to a malicious or fake site. The victim may think they are visiting a trusted domain, like a bank or email service, but instead land on a lookalike site controlled by the attacker. From there, the attacker can steal credentials, deliver malware, or conduct further social engineering. Another related threat is cache poisoning. In this attack, the attacker corrupts the DNS records stored in a local resolver's cache. When users on that network request the same domain, the poisoned entry sends them to the attacker's site. Because the response comes from the local resolver, users are unlikely to suspect anything is wrong. Indicators of DNS-based attacks include sudden changes in DNS response behavior, redirected traffic, or DNS requests pointing to unfamiliar or suspicious IP addresses. You might also see multiple DNS queries for the same domain in rapid succession, or activity from domains with very short lifespans. These signs often indicate automated tools or malware using DNS to communicate. To protect against DNS attacks, organizations should implement secure DNS practices. This includes using domain name system security extensions, known as DNS-SEC, to authenticate DNS responses with cryptographic signatures. DNS resolvers should be configured to refuse external recursive queries and to validate responses wherever possible. DNS logging and monitoring are also critical. Logs should capture query sources, response codes, and timestamps so that suspicious behavior can be reviewed later. Suspicious domains should be blocked through filtering tools, and alerting should be configured to flag anomalies like sudden spikes in DNS traffic or outbound queries to command and control servers. As you prepare for the Security Plus exam, be ready to identify signs of DDoS and DNS-based attacks. Know how amplified and reflected DDoS attacks differ, and understand the role of botnets in flooding systems with traffic. For DNS threats, focus on spoofing and cache poisoning as the core risks. You may be asked to recommend detection or prevention tools or to explain what network logs might reveal during one of these attacks. Thanks for joining us for this episode of the Bare Metal Cybersecurity Plus podcast. For more episodes, tools, and study support, visit us at baremetalcyber.com. And before you take the test, make sure to check out the practice questions in the book Achieve CompTIA Security Plus SY0-701 Exam Success by Dr. Jason Edwards. They cover every domain and are a powerful way to lock in your knowledge.